Iceland, a rugged island in the Atlantic Ocean, nestled between Greenland and Norway near the Arctic Circle, harbors a landscape that is both mysterious and breathtaking. Roughly the size of Kentucky and Virginia combined, this young landmass has some of the most active volcanoes in the world. Its vast, uninhabited landscapes include dramatic plateaus, mountain ranges, and fertile lowlands, distributed with long, deep fjords and glaciers, including the significant Vatnajökull. The island's terrain is a combination of waterfalls, geysers, volcanoes, black sand beaches, and peculiar boiling lava fields. But what has just emerged in Iceland? What discovery has sent shockwaves through the scientific community, causing both intrigue and alarm? Could this new finding reshape our understanding of Iceland's geothermal wonders, or reveal hidden dangers lurking beneath? Join us as we explore this mysterious revelation and explore its implications. Iceland, an island nation in the North Atlantic, stands as an example of Earth's fiery power. This country, sized at 103,000 kilometers square, is one of the youngest land masses on the planet. The landscape of Iceland is a striking blend of many geographic features, while the interior is dominated by the massive Vatnajökull glacier, the largest in Europe. The terrain is a mix of waterfalls, geysers, black sand beaches, and lava fields, reflecting the volcanic activity that has shaped the island. Iceland's volcanic activity is due to its unique position situated between the mid-Atlantic ridge, where the Eurasian and North American tectonic plates meet. This geological hotspot is the source of constant seismic and volcanic activity, making Iceland a living laboratory for geologists. One of the most significant volcanic events in Iceland's recent history was the eruption of Vatnajökull in 2010. This eruption gained worldwide attention as the enormous ash cloud it produced disrupted air travel across Europe for several weeks. The impact was global, affecting millions of travelers and causing substantial economic loss. Which is why what has emerged now in Iceland has scientists terrified. But Vatnajökull is just one of many notable volcanoes in Iceland. Others include Hekla, known as the gateway to hell in medieval times, and Katla, a highly active volcano hidden beneath the Mýrdalsjökull glacier. There's also Grímsvötn, Iceland's most frequently erupting volcano, located beneath the Vatnajökull glacier. The volcanoes of Iceland are not only agents of destruction but also of creation. The geothermal energy they provide is a significant source of power and heat for the nation. This energy powers homes, businesses, and attractions like the Blue Lagoon, a world-famous geothermal spa. Iceland's volcanoes have also played a role in shaping the island's culture and folklore. Stories and legends inspired by the fiery mountains and their eruptions are woven into the fabric of Icelandic history. Despite its sparse population, Iceland's volcanic activity has far-reaching implications. Volcanic eruptions can affect air travel, contribute to climate change, and even alter global weather patterns. Scientists closely monitor these volcanoes to understand their behavior better and to provide warnings of potential eruptions, safeguarding both Iceland's inhabitants and the broader international community. Iceland's relationship with its volcanoes is a complex interplay of awe, respect, and scientific intrigue. These natural giants are a constant reminder of the planet's dynamic nature and the deep impact geological forces can have on human civilization. Recently, in the serene landscape of Iceland, a discovery has emerged that has both intrigued and alarmed scientists. This revelation, found in the historically rich area near the small town of Oddi in Rangárvellir, has opened a new chapter in understanding Iceland's geology and history. The initial find was made during a standard archaeological excavation by the Archaeological Institute of Iceland. What they unearthed was a previously unknown man-made cave, believed to date back to the Viking era. This discovery was not only unexpected, but also significant due to its potential historical value. The excavation, which first began in 2018, revealed a much larger cave system than initially anticipated, connected to a broader network of underground structures. Local experts and historians believe these caves could be Vatnajökull, medieval barns used for livestock and horses. The size and complexity of the cave system suggest it was an integral part of the community in the medieval Icelandic Commonwealth. These findings confirm narratives found in Bishop Orlacour's Legends of Saints from the early 13th century, which mention similar structures. According to these texts, one such cave collapsed with 12 bulls inside, a testament to their use and significance during that period. Eyewitnesses from the archaeological team expressed their amazement at the size and sophistication of the cave system. According to their accounts, the interconnected caverns date back to between 800 and 1060 AD, aligning with the Viking Age. This period was a time of significant settlement and development in Iceland, and these caves provide a tangible connection to that era. The discovery goes beyond mere historical interest. Scientists are now pondering the broader implications of this find. Could there be more such structures hidden beneath Iceland's surface? What do these caves tell us about the lives of the early settlers in Iceland? And how did they manage to construct such complex structures with the limited technology available to them at the time? This discovery has captivated not only historians and archaeologists, but also the general public. It sheds light on a lesser-known aspect of Iceland's rich history, offering a glimpse into the lives of its early inhabitants. As excavation and research continue, more secrets hidden beneath the Icelandic landscape may come to light, each adding a new piece to the puzzle of this fascinating island nation's past. The recent discoveries in Iceland have raised significant alarm bells in the scientific community. While these findings have undoubtedly excited historians and archaeologists, they also pose potential risks and unknown factors that are causing concern among experts. The uncovering of the extensive man-made cave system, dating back to the Viking Age, has intrigued archaeologists. However, it also poses potential risks. The stability of these ancient structures is a primary concern, especially considering their age and the fact that they were only recently discovered. There is a risk of collapse, which could be dangerous not only for researchers working on site, but also for the surrounding environment. Additionally, the possibility of these caves harboring unknown pathogens or hazardous materials from the Viking era cannot be ruled out, posing a health risk to those exploring them. The theory of Icelandia, a submerged continent that could extend from Greenland to Europe if proven true, would challenge long-held beliefs about the composition of the Earth's crust in the North Atlantic area. The presence of a continental crust under Iceland, as opposed to an oceanic crust, could imply untapped resources, including minerals and hydrocarbons. However, this also raises environmental concerns. The exploitation of these resources could lead to ecological disturbances and heightened geopolitical tensions over resource claims in the region. Geologists and environmental scientists are particularly concerned about the potential impact of these discoveries. If the Icelandia hypothesis is confirmed, it could lead to aggressive resource exploration activities in a region that is already facing the brunt of climate change. Experts warn that any disruption to the already fragile ecological balance could have unforeseen consequences. Additionally, the excavation and exploration of the newly discovered Viking-era caves need to be approached with caution to preserve the site's historical integrity and ensure the safety of those involved. While these discoveries in Iceland open new windows into our past, they also bring with them a set of challenges and concerns that need to be addressed. Scientists are calling for careful, responsible exploration and study of these sites to ensure that the pursuit of knowledge does not come at the expense of safety, environmental stability, or historical preservation. To gain a deeper understanding, we turn to insights from geologists, volcanologists, and other experts who have analyzed the data and research findings central to these phenomena. The discovery of interconnecting caves near the town of Adi, dating back to the Viking Age, 800–1060 AD, has provided valuable insights into medieval Icelandic history. Archaeologists note the significance of these findings in understanding the settlement patterns and daily lives of the Vikings. However, geologists express caution regarding the stability of these ancient structures. They point out the risks of potential cave-ins, which could be triggered by natural processes such as erosion or seismic activity. There's also a consideration of preserving these sites, as they are vulnerable to environmental and human-induced damage. The concept of Icelandia, a submerged continent stretching beneath Iceland and the surrounding waters, has stirred debate among geologists. If proven, this theory would suggest that a large portion of land, previously thought to be oceanic crust, is actually continental crust. This has implications for our understanding of Earth's geological history, particularly the breakup of the supercontinent Pangaea. Experts argue that such a discovery could lead to a re-evaluation of the North Atlantic region's geological formation. Geophysicists are intrigued by the potential for new mineral and hydrocarbon resources if Icelandia is confirmed. However, they also warn of the environmental impact of exploiting these resources. The exploration and extraction processes could disrupt the fragile ecosystems in the North Atlantic, a concern echoed by environmental scientists. The supporters of the Icelandia theory have faced skepticism from some geologists who argue that more evidence is needed to substantiate such a significant claim. They emphasize the need for further seismic studies and deep-sea drilling to confirm the presence of continental crust in this region. Both discoveries have opened new avenues for research and study. Archaeologists and historians are planning extensive excavations to further explore the Viking-era caves, hoping to uncover more about the cultural and historical aspects of the Viking Age in Iceland. Geologists, on the other hand, are advocating for comprehensive geological surveys and studies to validate the Icelandia hypothesis. The recent geological findings present a complex scenario of ecological, environmental, and geological implications, demanding careful examination and forecasting. The discovery of the Viking-era caves near Oddi brings forth concerns about geological stability. There is tension that increased human activity, coupled with natural erosion, could potentially lead to cave collapses. Such events could not only destroy these invaluable historical sites, but also pose significant risks to nearby settlements. Preserving these caves is therefore seen as important, not just for their historical value, but also for environmental safety. Icelandia, the proposed submerged continent under Iceland, if confirmed, could radically change our understanding of Earth's geological history. This discovery might trigger a surge in mineral and hydrocarbon exploration, offering economic prospects. However, the environmental consequences of such activities cannot be overlooked. Disturbing the ocean bed in search of resources could detrimentally affect the marine ecosystems and biodiversity in the North Atlantic region. From an ecological standpoint, this might result in irreversible damages. Moreover, the existence of Icelandia could have far-reaching effects on global weather patterns. Scientists express particular concern about its potential impact on the North Atlantic Oscillation, a crucial determinant of weather conditions in Europe and North America. Such changes could disrupt established climatic patterns, leading to unforeseen weather anomalies. From a geological perspective, the discovery makes extensive research and surveys necessary, which could provide groundbreaking insights into continental drift and plate tectonics. A deeper understanding of the distribution of continental and oceanic crusts in the North Atlantic area is vital for accurate predictions of volcanic activities and earthquake risks. The theoretical presence of Icelandia also challenges established geological theories, prompting a reassessment of our current understanding of Earth's formation and processes. This could lead to new discoveries and theories in geology, extending well beyond the North Atlantic region. While the discoveries in Iceland are enthralling, they come with a suite of ecological, environmental, and geological concerns. As research unfolds, it is crucial to balance the excitement of discovery with the responsibility of safeguarding our planet's delicate ecosystems and rich historical tapestry. These discoveries are not only fascinating in their own right, but also shed light on past geological events that have shaped Iceland's landscape and influenced scientific understanding. Iceland's geothermal history is marked by numerous volcanic eruptions and seismic activities, a testament to its location on the mid-Atlantic ridge. One of the most notable events in recent memory is the 2010 eruption of Vatnajökull. This eruption caused significant air travel disruptions across Europe and drew global attention to the potential impact of volcanic activities in Iceland. It highlighted the interconnectedness of natural events and human systems, emphasizing the need for comprehensive scientific monitoring and preparedness. The current findings of the Viking-era caves provide a direct link to Iceland's past, reflecting the island's long-standing interaction with volcanic activities. These caves, believed to be man-made, offer insights into how early settlers adapted to and utilized the volcanic landscape for their needs. Their discovery compels a deeper understanding of Iceland's human history, intertwined with its geological past. This theory challenges the established notions of the North Atlantic region's formation and suggests a re-evaluation of past geophysical models. The potential existence of Icelandia resonates with previous significant geological discoveries in Iceland, each altering the scientific comprehension of the region. Comparing these current discoveries with past events, there is a clear pattern of Iceland's geothermal activities unveiling groundbreaking scientific data. Each event, whether an eruption like Vatnajökull or the uncovering of historical sites, contributes to a deeper understanding of the region's geology and history. Furthermore, these findings emphasize the importance of studying and monitoring Iceland's geothermal activities closely. Past experiences, like the widespread impact of the Vatnajökull eruption, have led to enhanced monitoring systems, better preparedness for volcanic events, and a more nuanced understanding of the global implications of such activities. The echoes of Iceland's past, revealed through its ongoing geological studies, continue to shape our current understanding and response to these natural phenomena. The intertwining of historical events and new discoveries not only enriches the scientific narrative of this unique island, but also fortifies our readiness for future geothermal activities. These recent discoveries are not isolated events. They form part of a broader narrative of global geological and environmental changes, highlighting how localized events can have far-reaching implications, especially in the context of climate change. The findings in Iceland are a reminder of the dynamic nature of Earth's geology. They demonstrate how shifts in one part of the world can offer clues about the planet's past and future. The discovery of Icelandia, for instance, challenges existing theories about continental drift and the makeup of the Earth's crust, potentially rewriting the geologic history of the North Atlantic region. Furthermore, these events in Iceland highlight the interconnectedness of the Earth's systems. Geologic activities in one region can influence global patterns, such as ocean currents, weather systems, and even climate. The potential implications of these Icelandic events are particularly significant in the context of climate change. The Earth's geological processes play a crucial role in the global climate system. Understanding these processes, especially in geologically active regions like Iceland, is vital for predicting future climate patterns. For example, volcanic eruptions can release large amounts of greenhouse gases, but they can also have a cooling effect on the planet by reflecting sunlight away from the Earth's surface. Moreover, the uncovering of these new geological features in Iceland could provide valuable insights into the Earth's past climate conditions. This, in turn, can help scientists develop more accurate models to predict how the planet's climate might change in the future. Such knowledge is crucial for preparing for and mitigating the effects of climate change. The recent geological discoveries in Iceland are not just of local or academic interest. They have significant implications for our global understanding of geology and climate. These findings remind us that our planet is a complex, interconnected system where events in one region can have global repercussions. As we continue to wrestle with the challenges of climate change, the lessons learned from Iceland's dynamic geology will undoubtedly contribute to our global efforts to understand and protect our planet. In response to the startling geological discoveries in Iceland, Icelandic authorities and the global scientific community have implemented a range of proactive measures. These strategies are designed to monitor, understand, and mitigate any potential risks associated with these phenomena. The approach is multifaceted, involving ongoing monitoring efforts, emergency planning, and international cooperation. One of the primary strategies is the continuous monitoring of geological activity. The Icelandic Meteorological Office plays a key role in this, utilizing a network of seismographs, GPS stations, and other sensor equipment to track volcanic and seismic activities. These technologies enable real-time data collection and analysis, crucial for early warning systems. In addition, satellite imagery and aerial surveillance are used to monitor changes in the landscape, such as the formation of new volcanic fissures or the shifting of tectonic plates. The Icelandic authorities have also developed comprehensive emergency plans in collaboration with civil defense agencies. These plans include evacuation procedures, public awareness campaigns, and coordination with local and international emergency services. The goal is to ensure that communities living in geologically active areas are prepared and can respond effectively in the event of an eruption or other geological hazards. Another significant aspect of the response is international collaboration. Icelandic scientists work closely with counterparts from around the world, sharing data and research findings. This collaboration extends to institutions like the United Nations, the European Space Agency, and various geological and meteorological organizations. By pooling resources and expertise, the global scientific community aims to deepen its understanding of Iceland's unique geology and its implications for the rest of the world. The recent discoveries have also urged research into the potential impacts of these geological events on climate change. Scientists are investigating how emissions from volcanic activity in Iceland could affect atmospheric conditions globally. This research is crucial for understanding the role of volcanic activity in climate systems and developing more accurate climate models. Finally, there is an emphasis on sustainable and responsible tourism in response to these geological phenomena. With the increase in visitors drawn to Iceland's unique landscapes, authorities are working to ensure that tourism activities do not negatively impact these sensitive geological sites. This involves regulating access to certain areas, promoting eco-friendly tourism practices, and educating visitors about the importance of preserving these natural wonders. The response to the recent geological discoveries in Iceland is a comprehensive effort that involves ongoing monitoring, emergency preparedness, international cooperation, research into climate impacts, and sustainable tourism practices. These measures are essential for safeguarding communities, advancing scientific knowledge, and preserving the unique geological heritage of Iceland. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable!